So today is the 17th day of the Make LeetCode 30-day challenge, and the problem will be find all anagrams in a string. So we are given a string S and a non-empty string P. We are asked to find all the start index of P's anagram in S. For example, in the first example, the result will be 0, 6 because at index 0 there is CBA, which is anagram of ABC here, and at index 6 there is a BAC, which is also an anagram of ABC. So how do we solve this problem? We can solve this problem in sliding window solution, and this solution will give us a time complexity and space complexity both in the linear. So let's see how do we solve this. So we are going to use the sliding window solution, and what's more, we will use the US, which count as the map for the S input string, and we count the frequency of each input character, and UP count the frequency of the character in P for anagram checking. So as we iterated through the array, the string, then we doing the statistical data of each character English alphabet, and if the current index is greater than or equal to the size of P, which means we will leave one or more character out of the sliding window. For example, if we are at E now, and then we cannot count C as the string to check. Why? Because the P size is 3, so we can only check back up to B. So the frequency of C has to be decreased. Say here, we have to decrease the frequency of C from 1 to 0. And the same is for this B too. The B will be decreased from 1 to 0, and at here, B will increment back to 1. And here, A will be decreased from 1 to 0 and back to 1. So this is how we solve this problem. And the time complexity will give in the linear one, because when we are going to check if we have the result to push back, then we have to compare two vector, and the two vector have the fixed size of 26. So the overall time will be 26 times by n, which is the linear, and space complexity will be linear as well. You might wonder why the space complexity is not the constant, because we have 26. Because if we consider the result as in the space complexity, for in this example, the space complexity will be linear because all the position in S will be pushed back into the result. So there will be a linear one. And let's see how do we implement this in code. So first of all, we iterate through the P string, and then we count the character frequency of the P string. So say UP C minus by K lowercase a to get the offset, and then for if I is greater than or equal to P dot size, that means we have something to decrease from our US, which is the order map for a string to calculate the frequency of each character. Minus by lowercase a decrease, and USSI same as a the increase. And if two map or say two vector are equal, the result dot push back I plus 1 minus P dot size. This is just a problem of 0 and 1 index. So let's see if this works. Okay, and get accepted. Thank you for watching today's video, and see you tomorrow. Bye bye.